Hi, trigonometry is a branch of mathematics that studies the relationship between lengths and angles of a triangle. So we are dealing with lengths and angles of a triangle. So first, let's take notes of the types of triangles we have. So for the types of triangles, we have the equilateral triangle, the isosceles triangle, the scalene triangle, and then the right-angled triangle. But mostly, trigonometry is normally associated with the right-angled triangle. So in today's video, our focus will be on the right-angled triangle. So what is a right-angled triangle? A right-angled triangle is any triangle which has one of its internal angle being 90 degrees. So with that being said, let's draw a right-angled triangle. And note, one of the angle is 90 degrees. So this here is a 90 degree. And so this is a right angle triangle. Now the right angle triangle has three sides. First, we have the hypotenuse. And we have the opposites and the adjacent. So the hypotenuse is the longest side of the right angle triangle, or the hypotenuse is the side of the triangle that faces the 90-degree angle. So this side is our hypotenuse since it faces this 90 degree. Aside the hypotenuse, we have other sides which are the opposites and then the adjacent. Now these sides of the triangle are with respect to the angle we are interested in. So if we are interested in this angle, which is our theta, then our opposite side of this right angle triangle will be the line that is opposite to the angle theta, and that is this side. So this side is opposite to our theta, and so this side will be our opposite. Now, there is one more side to the right angle triangle, and that is the adjacent. The adjacent is the line where the 90 degree and our angle of interest lies. And from our diagram, we can see that this line here is the line where we have the 90 degree and our theta. So this line here becomes our adjacent. I'll draw another triangle, then we figure the sides of that triangle. Now, I would want you to figure out where the hypotenuse, the adjacent, and the opposite is. I'd want you to pause the video and figure out yourself. So our hypotenuse is the line of the triangle that faces the 90 degree. And this is our 90 degree. This is the line that faces the 90 degree. So this is our hypotenuse. The opposite is the line that faces our angle of interest. And this is our angle of interest. This line faces our angle of interest. And so this line is our opposite. Now this line is our hypotenuse, this line is our opposite, and so this line becomes our adjacent. So if you got it right, then well done. If not, then don't worry. You'll be able to understand everything as we proceed into the video. Now we all know what a right angle triangle is, and we know all the sides of a right angle triangle. This brings us to our next topic, which is the basic trig functions. So there are three basic trigonometry functions, which are sine, cosine, and tangent. Sine in short is SIN, cosine is cos, and then tangent is tan. Now these basic trigonometry functions deals with angles, so they work with angles. Now before that, let's draw our right angle triangle again. So this is our right angle triangle. This is our 90-degree. This is our angle of interest. So this brings us to a very basic term I'm sure most of us have heard of, SOHCAHTOA. So SOHCAHTOA. So here represents where this S represents sine, the C represents cos, and then the T represents tan. So if we have a right angle triangle and we are interested in this angle, the sine of this angle will be equal to the opposite over the hypotenuse. The cos of this angle will be equal to A, which is the adjacent over the hypotenuse. And then T, which is the tan of our angle of interest, which is theta. So tan of theta will be equal to opposites over adjacent. So this is what this term means. Sine is equal to opposites over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. If we have this right angle triangle, this is our 90. This angle here is 30. This line here is 2. And this is x. To find x, so the line x here is opposite the 90-degree, and so this line becomes our hypotenuse. This line contains the 90-degree and our angle of interest. So this line becomes our adjacent. So we have A and H. So to find H, we can use cos. So cos of 30 is equal to the adjacent, which is 2, over the hypotenuse, which is x. Now when we make x the subject, x will be equal to 2 over cos 30. And 2 over cos 30 is equal to 2.3094. So knowing the angle and our adjacent, we can find our hypotenuse. Now let's draw this triangle again. And then this time we have our adjacent and our opposite, which is h. Now we are being asked to find h. So finding h, we have our adjacent and we have our opposite. So we move back to our trig functions. We have adjacent and we have opposites. So we can use tan, which is equal to opposite over adjacent. So we can say that tan of the angle, which is 30, is equal to our opposite, which is h, over our adjacent, which is 2. So h will be equal to 2 tan 30. And 2 tan 30 is equal to 1.1547. So this is how to use our trig functions. Now also, I know a lot of us have heard of the Pythagoras theorem. So again, let's draw a right angled triangle. We have our 90, then we have our hypotenuse to be A, our opposite to be B, and our adjacent to be C. Now, Pythagoras theorem states that this distance, which is A squared, is equal to this distance, which is B squared plus C squared. So the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So if we have a right angle triangle and our opposite is 4, our adjacent is 1, we can find our hypotenuse using the Pythagoras theorem. We know that hypotenuse squared is equal to opposite squared plus adjacent squared. So hypotenuse squared is equal to our opposite squared. Now opposite is 4. So this line is opposite our angle. So opposite is 4. So 4 squared plus our adjacent, which is 1. So the hypotenuse squared will be equal to 16 plus 1. So let hypotenuse be h. So h squared will be equal to 17. Now to find h, we take the square roots of both sides. So we take the square root of this and the square root of this. So this cancels this. Our h will be equal to the square root of 17. So this line will be the square root of 17. Now also, we can use the same theorem to find our opposite and our adjacent, given two sides of our triangle. So let's try that. So let's take another right angle triangle. We have our hypotenuse to be 5 and our opposite to be 3. Now we need our adjacent, which is A. But from Pythagoras theorem, we know that our hypotenuse squared is equal to our opposite squared plus our adjacent squared. So our hypotenuse is the line that is opposite the 90 degree. And this line is opposite the 90 degree. So this becomes our hypotenuse, and that is 5. So 5 squared is equal to our opposite, which is the line opposite our angle of interest. And this line is opposite our angle of interest. So our opposite becomes 3 plus our adjacent squared. So our adjacent squared will be equal to 5 squared minus 3 squared. So a squared will be equal to 25 minus 9. And a squared will be equal to, so 25 minus 9 will give us 16. Now to find a, we take the square root of both sides. So we take the square root of this and the square root of this. Square cancels the square root. Our a will be equal to 4. So now we know our 3 basic trigonometry functions, which is the sine, the cos, and the tan. And we know that sine of theta is equal to opposite over hypotenuse. And we know that cos of theta is equal to adjacent over hypotenuse. And we know that tan of theta is equal to opposite over adjacent. Alright, so we also know that from Pythagoras' theorem, the square of the hypotenuse, which is the hypotenuse squared, is equal to the opposite squared plus the adjacent squared. Now this is a quick twist. Tan can also be equal to sine over cos. So tan is not all that basic like we said. Now we know that sine is opposite over hypotenuse, and then cos is adjacent over hypotenuse. And we are saying that tan is equal to sine over cos. So this is sine, which is opposite over hypotenuse. This whole thing represents sine divided, so we have divided by cos, which is adjacent over hypotenuse. So everything here represents cos. So the whole of this represents tan. So this whole expression is equal to opposite over hypotenuse times hypotenuse over adjacent. Hypotenuse cancels hypotenuse, and we'll be left with opposite times 1 over adjacent. And this is equal to opposite over adjacent is equal to tan. This shows that tan is equal to sine over cos. Now with that being said, let's take a question. So question 1. If sine theta is equal to 3 over 5, find the value of tan theta. So first, to solve this question, we first need to draw our right angle triangle. So we draw our right angle triangle. We have our right angle, which is 90. Now we know that sine theta, so we have our theta here, is equal to opposite over hypotenuse. And you are saying that this is equal to 3 over 5. So this is equal to 3 over 5. This means that our opposite is equal to 3 and our hypotenuse is equal to 5. So our opposite is the line that faces theta, and this line faces theta. So this side will be our opposite, and that will be 3. Our hypotenuse is the line that faces the 90 degree, and this line faces the 90 degree. So this line is our hypotenuse, and that will be 5. So first we need to find tan theta. We know that tan theta is equal to opposite over adjacent. We know our opposite, which is 3, but we don't know our adjacent. So let the adjacent be x. But we know that from Pythagoras theorem, so from Pythagoras theorem, hypotenuse squared is equal to opposite squared plus adjacent squared. Our hypotenuse is 5, so 5 squared is equal to our opposite squared, and our opposite is 3 plus our adjacent squared. So a squared will be equal to 5 squared minus 3 squared, and a squared will be equal to 25 minus 9, which is equal to 16. So our a squared is equal to 16. We take the square roots of both sides, so this cancels this. Our a will be equal to 4. So now we know our adjacent is 4. So tan theta becomes opposite, which is 3 over our adjacent, which is 4. So tan theta is equal to 3 over 4. Now let's take another question. Question 2. Given that sine x is equal to 0.6 and x is between 0 degrees and 90 degrees, find 1 minus tan x, leaving your answer in the form a over b, where a and b are integers. So let's begin with our solution. So sine x is equal to 0.6. Now 0.6 in fraction is equal to 6 over 10. So sine x is equal to 6 over 10. So we draw a right angle triangle. And this is our x. We know that sine is equal to opposite over hypotenuse. And this is equal to 6 over 10. So our opposite is equal to 6 and our hypotenuse is equal to 10. So first we have our 90 degree. Our hypotenuse is this line, so this becomes our 10. And our opposite is this line, so this becomes our 6. So we know that tan of x is equal to opposite over adjacent. We know our opposite, but we don't know our adjacent. So let our adjacent, which is this line, be a. Now from Pythagoras theorem, hypotenuse squared is equal to opposite squared plus adjacent squared. Our hypotenuse is 10, our opposite is 6. So we have 10 squared is equal to 6 squared plus a squared. So our a squared will be equal to 10 squared minus 6 squared. So a squared will be equal to 100 minus 36. So a squared is equal to 64. Now to find a, we take the square roots of both sides. So we take the square root of this and the square root of this. Square cancels square roots. Our a will be the square root of 64. And that is equal to 8. So our adjacent, which is a, is 8. Therefore, tan of x is equal to opposite, which is 6, over the adjacent, which is 8. And 6 over 8 is equal to 3 over 4. So tan x is equal to 3 over 4. But from the question, we are supposed to find 1 minus tan x. So we are supposed to find 1 minus tan x. So this is 1 minus 3 over 4, and that is equal to 1 over 4. So our answer is 1 over 4.